Good afternoon, everyone. Welcome to this workshop organized by the InnovaMare project. This is a workshop focused on conceptual design for robotics, underwater robotics and sensors. And the idea is to help us design the robots and sensors that we should produce during the project as part of the Work Package 5, Cooperation in Innovation on Robotic and Sensor Solution pilot actions. Today we have most of the people attending this workshop are from InnovaMare project. I know that some of you invited some external, and I hope that this workshop will be interesting for all of you. I don't think it will be just interesting for the ones involved in the InnovaMare. We tried to have a workshop that is very practical, so we didn't want to have just a lecture on what is conceptual design or something like that. And that's why we went with 3 company speakers from very different backgrounds and places. The idea is to have a diverse range of speakers with different experiences and even different regions, so different business environments as well. We'll have one speaker from Buoy Robotics Norway, and that will be the first speaker. And this is a spin-off from the university, from the Norwegian University, Science and Technology University. Then we'll have a talk by Dr. Edin Kocho from Gideon Brothers here in Croatia. He's an alumni of FAIR. It's a pleasure to have him speaking to us. And then the last talk will be by the CEO and founder of Blue Robotics USA, Rustam Jehangir. And that's why this workshop is so late. This company is in California, so Rustam will be having an early morning for us. He'll start his talk at 8 or even 7 a.m.
Oh, nice.
But I hope that this will be interesting for all and they will keep your attention until the end. The idea is also that there will be presentations and a lot of time for questions. If we run out of questions and we have free time, we can do short breaks in between presentations to keep us active and fresh until the end. I think I can introduce now Andreas. We have, there's more people arriving, so I think I can start by introducing you. So, as I said, Andreas works at the Buoy Robotics in Norway. And he'll be presenting his work in the development of the Buoy Pioneer. So his presentation will be behind the scenes of making the Buoy Pioneer. This is the main product of Buoy, which is an underwater drone, super user-friendly and that does not require special skills to operate and maintain. The design requirements from day one were very focused on size and portability. Of course, without forgetting high performance, and with many iterations and testing, this product was born. Andreas was the first employee of Buoy, and he started in the summer 2015 while still studying Marine Technology at the University in Trondheim, Norway. And since then, he has been a key asset in the product development, working with both software and the outer shape of the hull. We are very excited to have Andreas here and to learn more about the design journey of the Buoy Pioneer and also about the new model they are launching this summer. Andreas, the floor is yours. We can have the questions all at the end. I don't know if you prefer people to interrupt you, just let us know whatever you prefer.
We could do it towards the end. That's okay.
Okay. Please, welcome again.
Can you see my screen now?
Yes.
Yeah. All right. Perfect. Thank you for the kind introduction. And as you said, today I'll share some of our experience and our story, taking the Buoy Pioneer from idea to a product in the market. So I'll start by just saying a little bit about myself. My name is Andreas Viggen, and I have a master's background from marine technology at the university here in Trondheim, with the depth of study, depth of field, it was the marine cybernetics. I started back in 2015 as a summer intern before the company was even founded. Then I did my project and master thesis the year after, and then started as a full-time employee in 2016. Back then, it was mainly iterating on the outer shape of the hull, playing with the hydrodynamics and the hydrostatics, make sure that it was behaving properly and yet producible in a mass production scenario. Later, I continued with the working on the control system in the drone. So working on key features such as the auto heading and auto depth, fine-tuning all the thrust allocation and user feedback. I also have done some work in the Buoy app, which is both for iOS and Android devices. So we have a really good user experience from our topside tablets. Later, I did some work on automatic processing on dive logs. That way we could iterate fast and find outliers in our dive logs automatically. This was very, very useful during testing because we had so much log data that we had to process in an efficient way to make sure that we picked up on faults early. I also worked with customer success, providing training all over the country, also in the US and Dubai, Singapore, etc. So I've been out meeting customers and listening to their needs. Yeah, so this is both for large companies in shipping and aquaculture and also hydropower. Last year, I was the interim marketing director for Oda, who was out in maternity leave. So I also have some of the branding and marketing perspective. And now I'm back as a senior software engineer, developing new integrations with the new hardware to our next version. So basically development on the Linux operating system, which is our own Linux-based or Yocto build OS running on the drone. So here is the team. We are a diverse group with lots of different fields of expertise. We have everything from in-house production of videos, and we have engineers, we have a sales team. We have about half the team is working with software. So it's basically, yeah, we have engineers for the camera, Linux OS, or the Linux is what we call it. We have app developers, embedded software engineers, and control system engineers. So it's a small company, but we have a wide variety of expertise. So then I'll share some of the background of the company. As I said, it was, or in the introduction, it was mentioned that this is a spin-off from the AMOS Center at NTNU, the Center of Autonomous Marine Operations and Systems. So this was founded by Erik Dyrkorden, Martin Ludvigsen, Kristine Spiten, and Erik Haugane back in 2015. And the idea was then to make a drone that was similar to the flying drones. It should be super accessible and cheap for the man on the street to get better access to the ocean. So we wanted to make sure that, or make the ocean and the problems facing us in the ocean more visible to everyone, so it would be easier to grasp these issues, environmental issues, and also more recently we focus more on shipping, fouling, which is also important for reducing the CO2 emissions and extra friction on the ship hulls. So our main product is the Buoy Pioneer, or the Buoy underwater drones in general, because we have multiple models. As you know, it's developed in Norway. We have always designed it for simplicity and robustness, so it should be polite, and you should be able to make sure that you can trust that it works every time. It should be simple to operate for anyone, not only the ones with specific experience or training from the ROV pilot world. It has to be CE certified. This is because we were targeting the mass market, of course, but also we see huge benefits of having it fully certified in terms of safety and making sure that everything works well and you can trust that nothing is dangerous in any way. And it's also safer in terms of operation versus divers, and you can do more jobs without putting down your stopping the main engine, or it's easier to get access below. So the challenge we solve is low friction access to view what's below the surface. And our target customers, it's professionals that benefit from frequent underwater inspections. So, as I said, it shouldn't be necessary to be like a dedicated ROV pilot to use this drone. It should be, with minimal training, anyone in your company can pick it up and very quickly start using the Buoy Pioneer as a tool. And today our main markets are the marine industry, aquaculture, ports and marinas, and we have offshore and hydropower becoming more and more important market for us. So to give you some examples, like applications in shipping are typically propeller and hull inspection, assessment after hull cleaning, biofouling, so making sure that the cleaning was done properly. It's usually done by a third party, and you want to verify that they actually did the job. We have heard some pretty bad examples in Gulf of Mexico, etc., that they only do clean parts of the hull and claim that they did the whole thing. And so some customers, they are actually using the drone to make sure that they can quickly have a look themselves and verify the job is to be done and what has been done. We also have multiple customers that have had great use of the drone when they have done like a soft grounding or touched the bottom in somehow, and then they could lower the Pioneer and quickly check if the hull was damaged and continue to sail with communication with class, etc. It's also used for checking where did you land your anchor, what's the bottom conditions around on the ship in that area, etc. It's actually also the large cruise liner, Viking Cruises, that got kind of the main engine stopped during a storm here at the coast of Norway, and they had to drop their anchor. And then, yeah, they dropped one of their anchors, and then finally they managed to catch ground with the second anchor. But the day after, they had to go back and find the first anchor, and then they used the drone to actually localize it. So that was another anchor use case. Yeah, so that's in shipping. In aquaculture, it's mainly used for daily checkups on the fish welfare, making sure the hideouts, it's like fake, what's it called? Algae or seaweed that the fish can use to hide out in. And then you have the lumpfish that eats the lice from the salmon. So to make sure that these processes is going properly, it's important to inspect and see if the lumpfish and the salmon is working together as they should, and that they are eating at the right places and stuff like that. It's also a general nice tool to see the general behavior of the fish. How stressed are they during feeding? Are they getting sick? Yeah, basically giving you a better insight to the fish welfare as well. In hydropower, it's used for regular inspections of the underwater assets, preventive maintenance, emergency inspections. It could be condition monitoring over time, so you could see, like, is the dam intact? Are the ceilings between the concrete parts intact, or are they starting to harden and potentially start a leak? Or are the gates functioning properly? Is it filled with debris? Stuff like that. So foreign objects and the intake. So they use it a lot also for tunnel inspection, which is very risky for divers to go in tunnels. And the alternative is to empty the tunnels for water and then have men walk in there after it's secured and make sure that the tunnel doesn't collapse because of the reduced pressure. So when you can just stop the water flow and put the drone in, it's a much safer way to inspect these tunnels. We also have some blog articles on our webpage on SFE here in Norway that did a construction of a new tunnel, where they actually film when they do the last explosion to make the tunnel, or the wet part, into the dry part of the tunnel. So that's exciting. So more over to what you're probably more interested in. So now I'm going to tell you a little bit about our journey from the first prototype, from the idea to the product that we have today. It started back in 2015, where we wanted to make a drone that was very portable and easy to take with you and carry yourself. You should be able to operate it as one person, and there shouldn't be like 5 pellet cases that you have to connect together and make sure all the connectors are cleaned and dry. And there are so many areas that can fail in this world of equipment. So we really wanted to reduce the required setup as much as possible to make it as fail-proof as possible. So you see this is basically the rough timeline of our prototyping. So we have changed both in size and weight, and tried the different concepts back and forth. So I'll walk you through these iterations and start with the PX, which is the one all the way to the left. But before we get into each model, I can show you some of the key concepts behind making an underwater vehicle, basically. So on conventional ROV design, the tether drag is like the dominating force on the vehicle. So on the larger ones, it's up to 80% of the drag or the thrust force. It's actually used just to pull the tether along with you. So reducing the square area of or the projected area of the tether is like step one in terms of reducing the required thrust. That's why we try to find a cable that's as thin as possible and yet has enough strength to get pulled by the drone. So yeah, as you see in the equation, it's the area is like squared, and it's also important with the current in terms of the speed part. The next point is when you have a thin tether and powerful thrusters, you are quite well off in terms of strength of the vehicle versus the forces it has to handle. This also means that when you have less drag in the tether, the drag on the main body or the vehicle itself becomes more and more important. So now it has to be hydrodynamically shaped because now the drone is moving faster. If you compare it to like a conventional ROV, which is more like a box design and has more drag in all directions, then we went for a more hydrodynamic shape that makes it fast going forward and agile in terms of yeah, going both deep and moving forward. On the next picture, you see the tether attachment point, which is another key design feature here, is to really get the attachment point of the tether as close to the center of gravity as possible, because that's basically the arm that will start to rotate your vehicle in pitch. If you imagine someone is pulling you in the tether upwards, the larger the arm is, the more pitch you will get on the camera. So on this image, I try to show the difference of connecting the tether close to center of gravity, the yellow dot, and then you could also connect it to the very back top end of the drone, but then you see you'll get a much longer arm, and that would result in a much larger pitch motion. The same goes for a sideway motion. If you look at the next figure, the shorter the arm is when the tether is dragging sideways, the better it is, and the less the drone will be forced to turn by the tether drag. This also means that since the thrusters actually come behind the attachment point of the tether, it makes it possible for the drone to turn even though you have strong forces pulling you backwards with the tether. The drone is still fully capable of turning. And this is important if you go, for instance, you go downstream the river and then all of a sudden you want to turn around. And if you do that too late, then it could be difficult to compensate this moment. The next important features are, features of our design is that we chose to have a standing design. This means that it's light on top and heavy at the bottom. So we have the buoyancy is basically behind the camera, and the battery and the weight is in the lower canister. And this makes it very statically stable. So no matter how you toss it in the water, it will always rise back up. And it's also tuned to have it's not like a super stiff design either, but it nicely converts back to neutral position upwards. So this also ensures that the drone is always standing up and down, no matter if the sea floor is a hill or going downwards, upwards, whatever 3D landscape you have, it's always easy to navigate because you know that my camera is pointing forward and it's everything is level, and it's easier to grasp like the space feeling. Yeah, and then I will also show you some pictures from the prototyping and first testing later. And then one of the first findings was that when the drone was going up and down for longer periods, like typically traveling from the surface to 20 or 50 meters down, it will come into this oscillation because of the oval shape of the drone, and you would get these vortices that was oscillating back and forth. So then the idea was to, what if we add something that could break these vortices, so we get smaller vortices that won't get into this eigenfrequency of the shape of the drone. So then we started playing with these fins. So all these fins, they are actually quite well known in the shipping world. Like you always have this bilge keel on the, yeah, it's like the outermost part of the main body of the ship. It's typically, what is it, 1/3 of the length of the hull, and it's about 15-20 centimeters out from the hull, and it greatly reduces the roll motion of both ships and drones. So we added these both at the bottom and at the top to add damping to the system. So this basically also helps in terms of getting the camera stable without wobbling back and forth more than necessary. So we knew that we wanted to have a standing design, so we could have buoyancy at the top and weight at the bottom. It should be, we wanted to have space for a DVL. We wanted to have a canister that you could rotate the camera in. So this is like the very first model or idea sketch. Yeah, and you see it's many of the main concepts that we have today as well. It's just a very rough first one. So then the next one we wanted to make a bit nicer. Of course, it had to be looking appealing because we wanted to make sure that this is something that doesn't look dangerous to use, or it is not super advanced only for drone experts or the most eager tech guys. So we wanted to make it look smooth and easy to use from day one, even though everything inside was super hacked. It looked quite finished on the outside. And as you see, when you open it, you have all this buoyancy inside, and we had separate canisters with the cables in between. It was all off-the-shelf components, just stacked together, cramped in this canister, and trying to make everything waterproof and just make everything work so we could start getting a hunch of how does it actually feel to drive this thing. And it's such a new experience for most people, so it was like both making the new product, making it waterproof at the, I don't know, 1/10 or 100th of the price. So it's very challenging task to make something that is so complex, but yet make it even much cheaper than what was available. So that was the PX, and as you see, it was pretty big. We had even fittings for 2 GoPro cameras in the front there, so you could flip them around and they could look upwards and downwards, and yeah, it's basically, and it's also the hardware inside that took more space because it was all off-the-shelf components with headers and everything, so everything was more bulky, and the battery canister was huge as well, with like 2 giant packs. We had more than 500 watt hours in there, so it was like a small little bomb. So after the first PX iteration, we quickly saw that, okay, this is still too big, we have to make it smaller. This is super hard to mass produce. There's so many screws, so many inserts, and too many plastic parts. And it would be really nice to have a sway thruster, because now we could always only drive forward. And if you were to go a bit sideways, you would have to back up and turn and go forward, like a car, basically. It's always hard to do the parking sideways. So we added the sway thruster, even though it caused a lot of pain in terms of fitting all the electronics and stuff around this big hole in the middle of the body. So, but we put it in there in the P1, which is the next model. Yeah. We also did enhancements of the battery pack. So now we got like a BMS and started to make sure that it doesn't short itself, that we could charge it externally without being afraid of the balancing, etc. And we added fiber optics instead of Ethernet cable. And this was to make it, like I said, the tethers as thin as possible. So fiber optics with the Kevlar inside. The downside of the fiber optics is that you need like a converter in both sides, and it actually turned out that the fiber optic cable was super fragile to bending. So even though we would still get data communication, it turned out that the more you bend the fiber optics back and forth, the more brittle it gets, and you get these small cracks in it, so less and less light gets through it. So it's not like when it cracks it doesn't work anymore, it just degrades slowly. So you could quickly go from 100 megabits to 10 megabits over just a couple of weeks of winding it up and down. So yeah, as you see, we had a good design team on board, X Design, and we did lots of iterations on both look, how does it kind of have a personality. It's almost like the robot IE, or it could look like lots of cartoons. So it's like having another key aspect is having the camera on top and the light as far away from the camera as possible, because then you get more distance to the particles that you film. So it's you get less reflections on the particle. It's similar to the moon. Like if you have the sun lighting the whole moon, you have like a full moon. But if you have the light from the back or from the side, you will get like a very thin moon, and that means you will get less distortion from the particles. Yeah, and then on this P1 we also started iterating on the buoy. So we wanted to make this floating buoy so you would get a greater reach. You could connect to the buoy with Wi-Fi, and the drone would basically pull the buoy after itself. So so you could cover larger areas, and it sounded like a great idea, but it also was really hard in reality. And this was both because of the sea surface is like super bad for Wi-Fi reflections, and you could get a wave that kind of partially get the antennas below the surface. So it was really hard to get a good connection. Another thing was that now the whole system is floating. So if you lose connection, you could risk everything just drifting away with the current. And if you have a limited Wi-Fi range, you could basically lose the whole equipment, because if you drift the wrong way, you would never be able to reconnect. And then it also turned out that the buoy had to be very large to have enough buoyancy to make sure that the drone doesn't just pull it under if you go down by accident, or if you, yeah, so it doesn't drown itself in a way. So we ended up calling it the surface unit, and took it on land and made it much smaller and much more user-friendly. So inside the P1, you see it was quite messy inside. You had all these motor controllers. We had the fiber switch on the lower left underneath the camera. We had like a big battery bank at the bottom with the custom BMS. The IP camera is there. You have a switch rack on the top. So it was a lot of stuff like just crammed in there. Another thing that was really special about this design is that, as you see, the whole lid is actually waterproof. So it's a massive piece of plastic that is machined out, and it has to be really thick so it didn't deflect or get a new shape when you got 50, 100 meters of pressure water on there. And we also had to make sure that the O-ring was completely sealed, and that's why we had this blue, it's actually children's paint. It's water-based paint, so if you get the water droplet on the inside there, you will clearly see where it came in, because that's always a nightmare to find the source of the leak. So just to make sure that all the O-rings are intact, etc., this is what we typically did in the prototyping phase. Yeah, so this was also the drone that was like the first time we could start testing this properly in the ocean. We could also get more into the user experience. How does it actually work to lower it in the water? Is it too heavy? How do you connect to it? Are everything going automatically in terms of connecting the video, getting the stream, getting the control signals through, stuff like that. But still, this was super hard to assemble because of all the parts and lots of things that could go wrong. Just to charge it, you needed like a magnet, and yeah, the list is long. And of course, it ended up being a nightmare with the potting of the connectors. We needed to find the right resin to make sure that we got good bonding between aluminum and rubber and stuff like that. So even though we thought it was the O-ring that was going to be the problem on this one, was the connectors that was difficult with heating and cooling down, and aluminum not sticking properly to the potting, etc. Last point is the vertical thruster, because we had like a tube going through the whole drone inside. You can't see it on this image, but it's basically a tube with a vertical thruster in it. So when you get close to the sea floor, it acts like a vacuum cleaner. So it kind of just sucks itself to the bottom. This means it will just make a fountain of a dust cloud that will easily come in front of the drone and into your image, and you can't see anything in that area for a very long time. So that's why we did some iterations on the vertical tube as well, splitting it and moving the inlet up on the side, so you don't get that suction effect, sucking up the sand and fine particles. But that you will see in the later iterations. Yeah, this is also the first model that we started to make more than one of. So we built 10 drones, trying to make like a mass production feel of it. And we had this inner frame that they all could be assembled the same way. Yeah, and then it's more about creating software that could be distributed easily to more than one drone. That's also quickly important when you get more vehicles. Here you see the first 10 drones assembled. Also taking some pictures, and that's the early team. This is actually from a Croatia trip back in 2016. This is like 2 weeks after I started full time. So we went down with 5 of these drones and tested it in really clear and nice waters. That was a good experience for us. So you could see on the right image that it was still pretty hacked with the duct tape holding the camera and the charging pins popping out there, and yeah, it's pretty rough still. And in the light you could see like prototyping of different light cones to how do we want to spread the light, etc. Yeah, and then we, as I said, the P1 was the first drone that we actually got to get in the ocean and get some hours on. Did it work diving along another diver? What kind of interaction do you get when you have a camera together with the topside radio, etc.? So now we actually started using it, and that was a really fun period. It was also very important for us from day one to go out in the ocean and test it properly to get the full experience of all the snag points that you can have from connecting to the surface unit, or when you lower it in the water, or is it getting moist on the inside because of the temperature differences, or there's so many things that it's difficult to think about when you're just testing in a lab. So it's actually easier to just go out and test the whole setup every time. Then we continued to the P2 Alpha. We had to make it even smaller. We wanted to add a gimbal in there to make the images even more stable. And yeah, it should still look appealing. So we started testing this P2 Alpha. It was super small, but we had to make sure that it behaved properly going up and down. So this is actually from the first tests of the P2 body. It was before it had its own motors. So we made this pulling test that we had a weight. You see it up on the, I think it's 3 meters. Right up there, you see the rope going up to like a pulley, and the drone would be pulled with a constant force due to the weight. And then you could see how the drone would act going up and down. So this is where we added the fins and did all the research in terms of measuring roll, pitch, and yaw with the different fins and placements and areas. So now you see that's the model in 2017, the P2 Alpha. And the next one is the P2 Beta. So that's where we wanted to reduce costs even more. So we had to remove the vertical or the sway thruster. So that's taken away. But then we quickly saw that but it's a really nice feature to be able to go sideways. So it was back again in the, I think it's Beta 5. It's the 2018 version. Yeah, so this is what we ended up with, the Blue Eye Pioneer. I'm not going to go into all the details of it. It's easy to find online. But I talked about some of these key features. It's like the distance between the camera and the light is important for the backscatter. We have the thin feather. We have the self-stabilizing design with the automatic heading based on the 2 IMUs with the 9 DOF compass, gyro, and acceleration. For as I talked about, the inlets on the side is lifted up to have less particles getting sucked in. It also allows the battery to go all the way through the main body. So that was also a good benefit. It's lightweight. You can carry it on an airplane. It's really fast going forward because the hydrodynamic shape has a great depth rating of 305 meters, and the tiltable camera came in with the Pro. So we have the mass production at Flex. So we did this scale up. So in 2019, we produced about 1,000 units in Poland, and this really required good test stations and yeah, a solid system, finding all the small bugs before we shipped it out, because we really had to make sure that it worked every time, because we couldn't afford to get all these drones back, right? Yeah, then we did the Buoy Pro. We added the tilt on the camera based on customer feedback. It was really a great need to be able to look upwards underneath the ship hulls. We added also the automatic pitch stabilization. So based on the IMU, we tilt the camera so it smooths the image. We increased the depth rating. By adding the dome, we could have more pressure on the glass. And we also had to change the buoyancy in the back. So small upgrades, but really, really important features from the market. So how do we choose what are the next features to produce? Then we go to our customers and ask them, what do they love with our product? What happens if we take the product away from them? What jobs can the drone do for them? And what would we have to change in order for you to be able to do more jobs with our drones? So then the typical answers we have gotten lately is to improve the waterproofing of the surface unit, because it's splash proof, but it's not waterproof, and it's like some weak points in terms of the antennas. So we have moved them on the inside, internal antennas, and made it waterproof. And then it's also being able to add more stuff, grippers, sonars, positioning systems, DVL, and also greater operation time. So we're now working on the next battery with more than twice the capacity within the same size. So we will fit all the previous drones as well, and longer tethers for greater reach. So coming soon is our next generation ROV. So if you want to learn more about our next model, you can join our online launch event on June 1st. And here we will show you what's new with the next Buoy drone, and is basically, as you can see by the pictures, it's the guest port, which allows for more equipment to be added, extra lights, camera, grippers, whatever you need. We have up to 8 protocols on these 3 guest ports, so it's very flexible in terms of adding all types of sensors and most of the underwater equipment that is out there. So just sign up for this online event and you will get a really nice introduction and actually also the first time we will share the launch video, so that's exciting. You can just Google, you'll find it on our webpage. That's probably the easiest. And then I also just wanted to throw in the Buoy SDK, which is, I think is really relevant for science and research, and probably many of you are into this field. So what's special about the Buoy is that we also have this Buoy SDK. It basically means that you can write your own software talking to the drone. So we have some examples with NTNU, who used two drones connected together to be able to carry this larger sensor and drive those two drones as one larger ROV. So that's super exciting stuff, and I just did a webinar on this topic, so if you want to learn more about our SDK, that's also fully possible here. I also had the joy to have Nadir join the talk and do a live demo, so that was really cool. And you also see it's well documented on GitHub, and it's very easy to get started both for students and professors, and you could quickly add a lot of value in terms of both logging sensors and post-processing of positioning data. You could do a lot of cool projects with being able to access your drones in this way. All right, I think that was everything I wanted to share, so I'll just open for questions.
Thank you, Andreas. Very interesting presentation. Anyone has a question? If we have plenty at the same time, please raise your hand. If not, you can just unmute yourself. Well, I have a question. Maybe some people are a bit shy still. It was very interesting to see how you had different designs along the years, and then you would add features and take off features and add them back, like the lateral thruster. So my question is, these design decisions, were they made taking into account end users' feedback, or like through this round of testing, were you involving people that you like targeting your future end users and partnering with these people, or was it an internal decision from the company?
Well, of course it's a bit both, but in the very beginning it was mostly our own inner gut feeling in a way, because we had so many issues in getting everything to work at the same time. So asking like the end customer, it would be too early, because he would just expect it to work first. So it's like it's always been a balance between following your own kind of gut feeling and ask the customer when the product is ready to be presented in a presentable way, in a way.
Sure. Okay. Matteo, please. Matteo is the InnovaMare project manager, so please, Matteo.
Hi, Andreas. Thank you very much for the presentation. I really liked it. I have a question regarding the testing grounds. I've seen a pool that you use as a testing, probably inside. But how do you?
You broke right now, Matteo.
Yeah. Is he coming back?
I guess so.
Do you hear me?
Now
now we hear. Yeah.
Okay. Do you have a pool that you do inside testing? Do you have any testing ground in the real environment? How do you test the product? Not only solely inside, but how do you test it in the real environment? You just let it in a sea, or you have any environment testing grounds in Norway?
Well, it's been at different phases. We have done different type of testing. Of course, we have done lot of testing in our small aquarium just to make sure that the thrusters are running. And then we have done some testing in a small pool in the basement, and we have done some testing in the towing tanks at the university to get the drag coefficients, etc. But we have definitely done most testing out in the ocean. So instead of building a larger pool ourselves, we bought a boat. So we have a small speedboat that is well equipped with the GPS engine and lots of charging, a lot of goodies, so we can go to great depths. And we've been testing on a lot of the airplane wrecks here in Trondheim, in the Trondheimsfjord. So we have wrecks from the Second World War that are at different depths from 70 to 180, 200 meters. Yeah. So we typically just visit the different sites and then see how it behaves in the current and different waves. And yeah.
The second question is regarding the battery. You said you will double up the capacity of the battery, right? What it means? You do it in-house, or you have somebody else doing it with you together, or you will do it all by yourself in-house regarding the battery system?
Yeah, that's with a partner. So that's like a project we do together with them, but it's a battery manufacturer that also do the certification. But the rest of the drone we have certified with our own third party, or Nemco. So it's fully certified with the CE for European products.
Great, thank you.
Yeah.
Other questions? If not, I have another one, but I'll rather first listen to other people. Okay, no. Well, yeah. I have a question regarding actually the certification and how it's basically. When did you decide it's ready to try the certification process, or like when did you decide this is the model that will go to the market, or like we need to stop iterating and now we are ready, and when to say, okay, this is the one that we are trying to certificate, or should we introduce first to the market without certification and go for it, test a little more? Like, what's the decision and the challenge of deciding this, of course?
Yeah, no, that's a really good question, and it depends. It's usually like a mixture between financiation and when do you kind of promise to have the product in the market. So you kind of have to try to meet what you promised, and that's also why you should never overpromise, because you just make everything harder for yourself. But, and then it's also about getting a feel for how much tuning do you need in terms to get it really solid. So it's always a risk adding more features towards the end. So when you have the deadline, you should really think twice before you add more stuff, because it always takes longer than you think. And as you saw, the P2 Alpha, it was on the sketchboard, it was planned to have a gimbal in there, but that we had to just take away because it was too high risk to have these moving parts inside there, 2 motors that were just like hanging. So we basically just took it away, fixed the camera, and put a flat glass to make sure we didn't get any reflections in the dome, and that was basically because of time. And you just had to when there's no time, you just have to cut the scope and make sure it works.
Sure. And one last question from me, when you wait, sorry, I forgot the question.
Let me ask Posto. I just ask you. You'll remember.
Sure. Please.
Just, it was interesting. You have a production in Poland. Is there a company that is specifically in production of these drones in Poland, or how did you came to this cooperation with the Poland company for production?
Yeah, that was. It's called Flex Electronics. It's like one of the larger electronic manufacturers in the world. I think they're like top 2 or 3. So they have multiple facilities all around the world, both in the US and Asia. And so then the one in Poland was the closest one for us, because we wanted to make sure that we could quickly scale to kind of reach the mass markets. But then we saw that the mass market, or at that lower price point, really, it never took off the way many people thought. So we had to increase the price and then go more towards the professional market. And that means that the volumes went down, and it would, even though we made 1,000 units, it was still way too low to make it feasible or efficient to have such a big production facility.
So you were going in the direction business to customer, to a private person buying this product, and then you saw that it's not possible with the price to get to this market, and then you just went to the professional market, right?
Yeah. And it's also about the as we came further along with the designing the internals, going from the plastic to internal canisters in aluminum. We had like double protection O-rings everywhere. So we didn't want to compromise on quality. So we just have to make sure that we make a good product, and then we'll figure out the correct price point for it when it's ready to be produced. So that's also why we had to increase the price and go professional.
Okay.
I remember the question. Actually, I had 2 short ones. Regarding certification, every time you add new features, do you need to recertify, and how much time this process takes, how complicated and expensive it is? And regarding the design features, when you redesign from one version to the other, do you have any special technique? Do you do like off-site meetings just for the design team, or like you dedicate 1 week just to think and brainstorm ideas, or is there any special process that you do for this part?
Yeah, if I start with the first question, it's basically once you have the ground certification, you could always do a gap analysis and do retesting and how is this performing towards your previous testing. So it's basically making sure that you still comply with the results and that your new design is not worse than the certified one. So and it's also a self-declaration in many areas. So as long as you have done the safety testing according to the specs, it's good. The second question was new features in the design team.
Yeah, on design, like what's your process? Do you have workshops or off-site meetings? Dedicated weeks, brainstorming.
Yeah, we have a yearly meetup at the. It's like a company cabin on an island out here. So we have these seminars when we talk and kind of make the plan for the next year. To decide on the next features, that's something we kind of always feel and share internally when talking to customers, and then kind of evaluating what's the most pressing features and just making sure that that we just don't jump on the most exciting stuff, but also do what is best for the company. So it's and it's always just being in business is also taking a lot of time. So making sure that the quality doesn't fall, even though you have had the product in the market for a couple of years. It's important to always not just work with new stuff, but make sure that the quality of what you have out there is both getting the proper support and also, yeah, getting good support and repairs.
Thank you. Any other question? We are slightly over schedule, but we have time for one question more.
Mm-hmm.
I think Massimo wants maybe to make a question. He just turned on his camera. No. No?
Massimo?
Well, if there's no more further questions, thank you again, Andreas. You are welcome to stay until the end of the workshop. If you need to leave for another meeting, we understand. But if you can stay and listen to the other speakers, that's perfect. The next speaker will not be on robotics. The third one will be up to you. It will be a pleasure if you can stay and interact.